Chapter 6 test. It says graph the area enclosed by the curves f of x and g of x. So let's do that. Cosine of pi x over 2. Okay, cosine curve goes, this is just going to change the period, so let's kind of figure out what's going on here. If we put in 0, 0 times pi over 2 is 0. Cosine of 0 is 1. So at 0, it's 1. If we put in 1, pi times 1 is pi, divided by 2 is pi over 2. And see, cosine of pi over 2 is 0. If we put in 2, we get cosine of pi, which is -1. So we've got this picture of the cosine doing something like this. And so it probably hits at -1, etc. So this is f of x. Now let's graph g of x. Oh, this is a parabola moved to the right 1. If you put in 0, if you put in 1, you get 0 squared, which is 0. If you put in 0, you get -1 squared, which is 1. If you put in 2, you get 2 minus 1, 1 squared, which is 1. So you get a parabola. So the area between the curves is this. So we graph the area enclosed by the curves, and this is what's enclosed, this bottom boundary and the upper boundary. So now set up the integral to find that would find the enclosed area. Now we don't have to solve them, just set it up. They must be in terms of only one variable. Okay, I could do it vertically or horizontally, but the easiest would be just to say the highest curve minus the lowest curve. So it'd be the integral, and we're going to go from 0 to 1 of the highest curve, which is cosine pi over 2x minus the area under the low curve. So the area under the high curve would be all of this minus the area under this curve. So we subtract x minus 1 squared dx. The top curve minus the bottom curve. So there's the setup. That's all I asked for. Number 2. Graph the area under the curve and in the interval 0 to 2 of this. Again, we have a parabola. It factors. So it's going to have, I'll draw it right here, an x-intercept of 0, an x-intercept of 2. At 1, it's going to be 1 times 2 minus 1 is 2 is 1. And it's going down because it's negative x squared. Got my units on my graph and got the graph. And we're going from 0 to 2. And the area under the curve, that would be this area. And then it says, determine the integral that would find the volume of the solid by rotating the area about the x-axis. So we're going to take this, and it's going to come up and go back down here. And this curve would go down to here. And this curve would go down to here. Draw that image if you need it. And that's about the x-axis. So it's coming up, over, down, behind, and back out. Okay? Now, probably the easiest to do on this is what we did first. A slice, which then would have, and I'm slicing it this way, and it would spin around and come down to here. And so it would make a circle. And so to find the area, the volume of this slice, this disc, we'd have to do the area of the circle times the thickness. The thickness is, since we sliced it perpendicular to the x, the thickness is dx. So the volume would be the area of the circle times the thickness of it, because it's pi r squared. H is the volume of a cylinder, and this is just a really short cylinder. And we'd integrate this. Well, this is in terms of x, so x goes from 0 to 2. So our variable needs to be x. Well, the radius is in that direction, which is y. Y is equal to the radius, but y is also equal to that. So we're going to have the integral from 0 to 2 of pi, which is a constant coming out, 2x minus x squared. That's the radius, and it has to be the radius squared dx. Now to finish this off, I'll go ahead and square this. So I'm going to take 2x minus x squared times 2x minus x squared. 2x times 2x is 4x squared minus 2x to the third minus 2x to the third plus x to the fourth. So my integral would change to pi integral 0 to 2 of 4x squared minus 4x to the third plus x to the fourth dx. Integrating this, I get pi. So I would go to the 3, so it's going to be 4x to the third over 3 minus, going to the fourth and dividing by 4, it would just be x to the fourth. Going to the fifth would be plus x to the fifth over 5. Evaluated from 0 to 2. Which, putting 0 in there, and there, it's going to wipe all that out. So it's just going to be pi times 2 to the third is 8 times 4, 32 thirds. 2 to the fourth is 16 2 to the 5th is 32 fifths, which if you have trouble with the fractions, keeping them in order, you can just type this all in the calculator, second pi. Now let's do this clear. Let's do 32 divided by 3 minus 16 plus 32 divided by 5. Enter. And then we can change it to a fraction by math. Enter. Enter. So this is 16/15 pi. Or if I were to type this in and just get the decimal, I would take this times pi, and I would get an approximate answer of 3.351. Number 3. So the population of a town has a radial density of this, which means if this is the center of the town, as you go out, the population gets thinner. So at a certain distance out here, the amount of people per square kilometer would be a certain amount. So what we want to do is do a ring out here. Which is out some radius, but the width of the ring would be then dr if this is the radius. So the area of this ring, it is a bent rectangle, but if this is really short, we could just say it's dr times the distance around. Now the distance around a circle is 2 pi r. So the length of the rectangle is 2 pi r. The width of the rectangle is dr. So there's the area of the ring. Now if we take the area times the density, the number of people per square unit of area, so if we multiply these two, we'd find out the total population on that ring. So we would take 300 times 1 plus 0.5 r squared to the negative 1, the density times the area, and the area is 2 pi r dr, and then we just have to add up for all the rings, add them up, all the rings, starting from the center of the city and working our way out 4 kilometers out. So now let's find out that population. The 300 is a constant, that's time stuff, so it comes out. So does the 2 and the pi, but not the r. So 2 pi times 300 is 600 pi. And the minus 1 means we have 1 over 1 plus 0.5 r squared times r dr. Okay, well, the derivative of this will produce an r, so I'm going to let u be the 1 plus 0.5 r squared. Then du equals, derivative of 1 is gone, 2 times a half is 1r dr. So dividing both sides by r, I get dr to be replaced by du over r. So this integral becomes 600 pi. I've changing my variable to u, so my limits would either change or I have to change back in terms of r. Let's see what the new limits would be. If I put in 0 for the r, I get 0 plus 1, which would be 1. If I put 4 in, 4 squared is 16. Half of 16 is 8, plus 1 is 9. I'd have 1 over u r, and dr is du over r. The r's would cancel, and I'd have the integral of 1 over u du, and that is, the integral of 1 over u is ln u, and we're going to evaluate that from 1 to 9, or we can put this back in and evaluate from 0 to 4. So putting 9 in there, minus putting 1 in there. Well, ln of 1 is 0, so I have 600 pi ln 9, which equals about 4,142. In the town. Whoops. Okay, number 4. When you do these, I want to see how you're thinking about this. So show me on the diagram. It says a square-based pyramid with a base edge of S. And since it's a square, this is also S. And the height from the center of the base to the top is H. Now, to find the volume of a solid, we basically take a slice, or we do the shell, but this doesn't have an axis of rotation. So I'm going to take a slice. And my slice would be parallel with the base. And I'll just call the edge of it X. And I'll put here Y. And now I have to find it. Now, some of you wrote the formula for the volume of this. Now, that's what you're supposed to find. You don't have it, you're trying to find it. So, we start with the volume of a slice. Now, the slice has a thickness. It's basically a box. Rectangular solid. Its thickness is dy. And we want to add up all these slices from the bottom to the top, or from the top to the bottom. So I'm just going to say from 0 to the whole height, h. The volume of the slice, which is just going to be x times dy. That's it. All we have to do is integrate this. Oh, wait a minute. We got an x, and it's dy. Well, let's see. This little pyramid is proportional to the big pyramid because it's same angles and all that kind of stuff. So x, this distance here, which I want to solve for, I'm going to start with it. X is to s as y is to h. I want to replace the x, so I solve for the x by multiplying by s. And so I now have integral from 0 to h of x squared would be y squared s squared over h squared, because x is ys over h. So if I square that, square it because I need x squared, I get this. Well, s and h are the fixed dimensions of this pyramid, so I can pull those out. They're constants. So I got the s squared over h squared, integral from 0 to h of y squared dy. Which integrates to y to the third over 3. We still have the s squared and h squared out here that we have to evaluate from 0 to h, which, putting the h in here, I have the s squared and the h squared, and I'd get h to the third over 3. Then put the 0 in, I get minus 0. So if I take s squared over h squared times h to the third over 3, 2 of the h's cancel 2 of them and only leaves one h, and so I'd have s squared h all over 3, or 1/3 area of the base times the height. That's the formula for the volume of a pyramid, a square pyramid. Okay, go to the next page. There's only a couple people that were able to do this one. Got all tangled up in this, so I'm going to be careful and do this nice and slow for you. So I'm going to draw my x-axis here, my y-axis here, and I'm going to draw 4 minus x squared. That's a parabola moved up 4 and upside down. So if I move over 1, it's down 1, or if you wish, you put in 0, you get 4. Put in 1, you get 3. You put in 2, you get 0. So the parabola goes like this, and it would keep going down, and it would come down on this side. Y equals 0 is the x-axis. X equals 0 is the y-axis. And from 0 to 2, that's for the x's, 0 to 2. So I'm talking about this portion of the parabola. So now I've made my graph, but one other thing I should put on there is the axis of rotation. This thing is rotated about y equal minus 1. Most people got that correct, but didn't draw it very well, or didn't show it. Y equal minus 1 is down here. It's not up and down. Okay. Now I recommend that if we're going to rotate it around this, we see where the points go. This one that's up 4 is actually 5 from this axis. So when it spins around this axis, it'll go to 5 below it. 1, 2, 3, 4, 5. It'll be clear down here. This one, which is 1, 2, 3, 4 above the axis. Here's the x-axis, but here's the axis of rotation. 1, 2, 3, 4 above it, so we've got to go 1, 2, 3, 4 below it. And then this one that's 1 above it would go to 1 below it. So this would go to here. This line of the x-axis, its image would be here to enclose the shape down here. So we have this shape that goes out and comes back, and this goes around here. And so that's what it is. I hope you can kind of visualize that. This is where some people are having a lot of trouble. Now, if I'm doing disk method, it's always slice perpendicular to the axis of rotation. So here's the axis of rotation. So I make a slice. I'll make it right here in the original. Now I'm going to see where those reflect to. This point right there would go down to here. This point there would go down to there. You notice I took it the same distance above the axis, down below. Same distance above the axis, I went down below. So the image of this slice would be down here. And since this goes around and this goes around, I'm going to get a washer. A washer that looks something like this. To find the area of a washer, you take the area of the big circle minus the area of the small circle. So that's what I have to write in my integral. The integral of the area of the big circle, pi r squared minus pi small circle. Okay, but what's my differential here? Well, if this slice is perpendicular to the x-axis, its thickness is dx. So I'm going to have dx. And x for this shape goes from 0 to 2. So that's the integral, except I don't have it down to a single variable, the variable x. So what is the large radius? Well, if this is my x-axis, from here to here is y. But I need to go from here to there. So it's going to be y plus 1. Y plus 1 more unit. So that's what my big radius is going to be. Now you notice there's pi in both of these. So I'm going to factor that out. 0 to 2. The big radius is y plus 1, but I need it in terms of x. Well, y is 4 minus x squared. So I'm going to have 4 minus x squared plus 1. Y plus 1. That's the radius, and I need to square that. So this is pi r squared. So that would be the area of the whole circle if there wasn't a hole in it. The whole disk. And if I take it times dx, that would be the volume of the whole disk. Pi r squared times the thickness. Okay. But there is a hole, so I have to subtract the hole. Now, what's the radius of the hole? Well, it's always just 1. So pi 1 squared. The hole in this always has a radius of 1 because it's 1 from the axis. So this is all I need to do to show the setup. That would have gotten you the 4 points for the setup. Now some of you clean this up a little bit. You said 4 plus 1 is 5 minus x squared. So you said pi integral 0 to 2 of 5 minus x squared, quantity squared minus and 1 squared is 1. So that's the setup for the disk method, a slice perpendicular to the axis. Okay? Now, let's set up the shell method. It's going to be a little hard because they're going to have to keep sliding this back and forth. Now, in the shell method, you do not slice, perpendicular to the axis. You slice parallel to the axis. Let me do the slice. I don't have a green pen, I don't think here. Yes, I do. Slice parallel the axis. So I'm going to do a slice right about there. So now the thickness of this slice is dy, and where that image is, see that's 1 and some up, so 1 and some down. It would be here. And it's still revolving around the y equals minus 1. So this point goes down to here. This point goes down to here. And so I get this ring, not a washer, but a ring, like a piece of pipe. Has some thickness, and it goes around and it goes behind, and it's a piece of pipe. Okay, so So that we can see this, I'm going to set it up right here, even though it says shell method down here, but I want to set it up where you can see me setting it up. So to do the volume of a piece of pipe, I'll draw this. Oop, boy, I didn't make that look very good. And it has a thickness. Piece of pipe like that. This thickness here is dy. Just that little thin thickness there. And this, just like in the city's population, we have the distance around this, so that we have the area of this rectangle that's bent around. The ring around it is, all the way around, is 2 pi r. And then if we take the ring around it times the height, we get times the height, this distance here, which is that distance. We'd have the volume of the ring. And we'd have to add up all the volumes of rings. Okay, so we're doing dy. So we'd like to have this all in terms of y, but I'm not going to worry too much about that. I'm doing rings. So where do I integrate from? Well, the smallest ring would be when it's right here. Has a radius of 1, but what is y? It is 0. And y will then, this dy will go from 0 all the way out here to 4. Okay, so now I have to do 2 pi r times h times dy. 2 pi r, the distance around, times the dy times the h. So now I got to get this in terms of y. So I have the integral from 0 to 4 of 2 pi r. The radius of my ring going from here, well, the x-axis is here, so the distance up to here is just y. It's in the y direction. But I have to go clear down to here. So I have to do y plus 1. So my radius is y plus 1. If I spun around the x-axis, it would be just y. But since it's 1 below it, the radius becomes y plus 1. What's the height? Well, that's this way. Well, that's x. But x, we have to have it in terms of y, and up here, this says that x is how x relates to y. So we have to use that to figure out what x is. So if I have y equals 4 minus x squared, if I add x squared to both sides and subtract y from both sides, I get x squared equals 4 minus y, and x would equal square root of 4 minus y. So that would be that length right there, the x direction, the height. And so I take the h out and put in square root of 4 minus y dy. So there's the setup for the shell method. Okay? They call these rings shells. Okay, now I'm going to do both of these, integrate both of these. So since the shell's right here, I'm just going to continue down here on the integration of it. Well, I don't care for the 4 minus y under the square root, so I'm going to let u equal the 4 minus y. So then du would equal negative dy. So I'd replace dy with negative du. The 2 pi as a constant will come out. The integral that used to go from 0 to 4, but now that I'm switching to u, 0, 4 minus 0 would be 4. So the 0 becomes 4. And when I put the 4 in, 4 minus 4 is 0. So I switched from 0 to 4 to 4 to 0. Not very exciting, pretty much the same, except they're just backwards. Then I have y plus 1. I wasn't working with that. I was working with the 4 minus y, which is square root now of u. And the dy I'm replacing with negative du. Okay, so what can I do now? I still have a y. So I'm going to solve for y in this, because I needed to get it in u. So I'll add y and subtract u, so I'd have y equals 4 minus u. So I have 2 pi integral from 4 to 0 of 4 minus u plus 1 times the square root of u, and then a negative can come out, du, which then becomes negative 2 pi integral from 4 to 0. 4 plus 1 is 5 times the square root of u, so I'm going to write 5 u to the 1/2. And then I'm going to have a minus u times u to the 1/2, which is going to be minus u to the 3/2. Now I think I can integrate that, so that's negative 2 pi. So this would go to the 3/2 and times 2/3. So I have 5 times 2/3 u to the 3/2 minus, this will go from 3/2 to 5/2, so I'll have 2/5 u to the 5/2. Evaluated, since I've changed my limits, I can go ahead and put in 4 and 0. Now I could take this minus and change the order of this, change it to 0 to 4 and change the sign of the minus. But yeah, let me do that. So I'm going to go swap that. So this will become 2 pi, and I'll put in 4 first because I'm switching this. I'm going there, switching that, changing this to 0 and this to 4. So I'm going to put in the 4, and so I have 5 times 2, that's 10/3 times, if I put 4 in there, The 2, then the denominator of the power says take the square root. So the square root of 4 is 2, cubed is 8, minus, put the 4 in here, and I'd have 2/5 times square root of 4 is 2 to the 5th is 32. So I've almost got it here. So I have 2 pi 80 thirds minus 64/5. And that's times 2. So let's just pull out the calculator and let it do the fractions for us. 80 divided by 3 minus 64 divided by 5. Math, enter, enter. So that's 208/15 times 2, 416/15. Some calculators you might have to go change it to fraction again. But so I have 416/15 pi, which is 87, oops, okay, maybe that's right, 87.12. Let me see what I had here before. I had slightly different. Where did I make an error? 80 minus 64/5 times 2 pi. 80 thirds minus 64/5. Did I type something wrong here? Let's go back up. 80 thirds minus 64/5. Okay, I think that's right. All right, let's see if the other one comes out to be the same answer. Okay, so the other one, I'll rewrite it down here. It's the pi, I'll show it up here so you can see, pi integral from 0 to 2 of 5 minus x squared, quantity squared, minus 1 dx. Okay, so I'm going to take 5 minus x squared times 5 minus x squared, because it says square that radius. So I get 25 minus 5x squared minus 5x squared plus x to the 4th. So I have pi integral from 0 to 2 of 25 minus 10x squared plus x to the 4th minus the 1 squared, which is 1, dx. Well, 25 minus 1 would be 24, minus 10x squared, and x to the 4th. So integrating that, I would have pi 0, integrating it. This would be x to the 5th over 5 minus, see, that would go to the third, so it would be minus 10 thirds x to the 3 plus 24x evaluated from 0 to 2. Okay. Well, evaluate from 0 to 2. And so 0 is not going to cause anything. So I just got to put 2 in there. So this would be pi, parenthesis, 32 fifths. I had 32 times 2 fifths before, but this is 32 fifths. Putting 2 in there, I got 8 times that. That'd be minus 80 thirds. I did have 80 thirds. And then this would be plus 48. Now let's see what those fractions come out to be. So I have 32 divided by 5 minus 80 divided by 3 plus 48. Math, enter, enter. 416 over 5. And I think that's over 15, which is what we had before. 416 over 15 pi, which is 87.12. So either way, we come up with the same answer. Now, you didn't have to work both of them out, but I worked both out, so just in case you tried one or the other, I wanted you to see how to do either one of them. Okay, the final problem. This says, I'll put something underneath it here so it's a little easier to write. We're going to pump the water out of this. And I can put the axis at the top or at the bottom, doesn't matter. But what I do want to see is that you think about a slice of this cone, this volume, this disc in here, that you have to lift to the top of this cone to get it out. So we're doing M, A, D, and D is the distance you're lifting it. So, what is that distance? Well, we could call this Y, but I see that we're going to end up with similar triangles in here. We're going to have this big triangle and this smaller triangle that I'm going to have to use to figure out the relationships here. So I'm going to choose, just because of that, I'm going to let Y be this. Now it's set up here, the height of this thing is 8 meters. So the height here, the distance I'm lifting it, is going to be 8 minus Y. So my D is going to be 8 minus Y, the distance I lifted. Now, the mass, the A is easy, that's the 9.8. So, and that always comes out of the integral. But the mass is density, and for water, it's 1,000 kilograms per meter cubed. But to get mass, we have to take it times the volume. So we need the volume of this disc. Well, it's a circle. It's got a radius. We'll put that on there in red. The radius and times the area. So it's going to be pi radius squared times its thickness, which is in the y direction, so it's dy. So there's the start of the setup, but we don't have it all in terms of y. Okay. The 9.8 is a constant. It's out. The pi is a constant. I'm going to take it out. The 1,000 is a constant. I take it out. This 8 is added or subtracted and times this stuff, so I can't take it out. It's only the ones that are times. So 1,000 times 9.8 is 9800 times the pi. Oh, and what am I integrating this from? Well, I'm doing dy, and so y is going from 0 to 8. Or 8 to 0, it's draining, but we'll just go 0 to 8. So I've taken care of this. We've got this inside 8 minus y. We've taken the pi out. We've got to replace the r. There's the r. That's what I want to replace. So I'm going to start my ratio with r. R is to, well, let's go to the red triangle up here. See, this was, the diameter is 6. All the way across is 6. So this is 3 meters. So the radius to 3 meters is equal to, on the triangle, the height of the green, because the red was off of this. This was the small triangle, so that would be y is to this length in the other one, which is 8. So solving for r, I'd multiply both sides by 3. And r would equal 3/8 y. So r squared would be 9/64 y squared. So that's what I'm going to put in for r squared. 9/64 y squared dy. Now I have it set up for integrating. I could take the 9/64 out, so I have 9800 pi times 9 divided by 64. Integral from 0 to 8 of y squared. This is now out, so y squared times 8. And y squared times a minus y. Okay, so I have 9800 times 9/64 pi. Just rearrange those a little bit. I can integrate this now. I'll raise it to 3, and so it'll be 8y to the third divided by 3 minus, raise it to 4 and divide by 4, so y to the 4th over 4, evaluated from 0 to 8. The 0 will make all that 0, so all I have to do is put the 8 in. So I have 9800 times 9/64 times pi times 8 times 8 to the third is 8 to the 4th over 3 minus 8 to the 4th over 4. Now you can just type that in your calculator, but I'm going to go ahead and factor out the 8 to the 4th. So I'm going to have 9800 8 to the 4th, 64, a 9, and I'm going to have 1 Oh, and there's a pi. And I'm going to have 1/3 minus 1/4. So that's 4/12 minus 3/12, which is 1/12. Just to check my work. 1 divided by 3 minus 1 divided by 4. Math, enter, enter, 1/12. But I could have kept this in here. The only reason I took this out is because 8 squared is 64, so this would change to 8 squared and cancel the 64. And I could probably reduce even more here. The 3 and the 9 would make this a 4. And the other 3, so the 3's gone, and the 4 could go into the one of the 8s, and so I'd have 2 times 8, which is 16. 16 times 9800 times 3 pi. Now, let's see what that is. That would be 16 times 9800 times 3, 470,400 pi. Let's just make sure I did that right by going back here and doing 9800 times 9 divided by 64. And I'm going to keep the pi out for a moment. So I got to do parenthesis 8 to the 4th divided by 3 minus 8 to the 4th divided by 4. Got the same answer. So this is correct, and if I multiplied that by pi, I get 1477805. Okay.